Hello everyone, in this video you are going to see the revision notes of unit number 3, a thermal insulation. So what do you mean by thermal insulation? These are those material or a combination of material which retard the heat flow by performing one and more operation. That is, first one, conserve energy by reducing the heat loss or gain, control surface temperature, increase operating efficiency of heating and ventilation and cooling, prevent or reduce damage to the equipment from exposure to the fire or corrosive environment, reduce emission of a pollutant to the atmosphere. Then this thermal insulation are been classified as per the temperature range. Low thermal low temperature thermal insulation, it is ranging from minus 273 to 15 degree centigrade. Intermediate temperature thermal insulation ranging from 16 degree centigrade to 3 315 degree centigrade, and high temperature thermal insulation ranging from 316 degree centigrade to 815 degree centigrade. So depend upon the temperature application you have to choose the thermal insulation. Now there are other categories, just like a generic type and a form of an insulation. So it is in a form of a fibrous insulation, glass wool insulation. Then a fibrous insulation, you have example of glass wool insulation and mineral wool. In cellular insulation, you have example of a polystyrene, elastomeric, and in granular insulation, you have granules of a calcium silicate and a cellulose. So the principle of using the insulation here is you have to create an air gap in the material so that it could retard the heat flow. And which kind of a heat transfer takes place in a air gap? That is convection. So it will be a combination of conduction and convection. Therefore the retardation of heat flow takes place after using this kind of a insulation. So different characteristic you must go through first of all to choose the thermal insulation. First of all, the temperature limit, then the thermal conductance, thermal conductivity, emissivity, thermal resistance, acidity, appearance, chemical resistance, coefficient of expansion and contraction, fire retardancy, resistance to the fungal or bacteria growth, and last one is the toxicity. To classify this insulation, again it has been classified depend upon the R value. What do you mean by R value? It is the resistance value of the insulation. Its unit is meter square Kelvin per watt. It measures the performance of an insulation, and it is only account for a conduction. The R value is inversely proportional to the heat transfer through the object, and the higher the R value, the better is the insulation. So R value should be maximum as possible, so it is going to provide a insulation to the wall. Economics of the insulation, as you can see, the insulation, if the insulation thickness increases, the insulation cost increases, but the energy cost decreases. So finding an optimal point here, it will be a total cost, that is A plus B. So to analyze the economic of insulation, a payback analysis method is been used. A simple payback period is equal to investment required to the net annual cash inflow. A payback period, it is also been given in the ratio of cost of an insulation to the difference between uninsulated cost minus insulated cost. Now here a simple payback period is going to give you a specific time for which your initial investment are returned. So this period is going to tell you that how much period it is going to take place for returning your initial capital investment. Now in the chapter 2 you have a transient heat conduction, or it is called as a unsteady state heat conduction. The transient word is related with the unsteady state heat conduction. So here the temperature is a function of a time. In an unsteady state heat conduction, the temperature of a function, temperature is a function of a time. So T is equal to f of t. The net rate of heat flow is equal to rate of change of internal energy. The rate of change of internal energy is given by minus mcp dt by dt, where capital T represents a temperature and small t represents a time. The negative sign here specifies that the heat flow out causing decrease in a temperature, resulting in a negative value of dt by dt. So if you plot a graph between temperature with respect to time, you will get a negative value of a slope. So in order to balance it mathematically, we have added a negative side in front of it. So negative mcp dt by dt. It's also follow the sign conventional. The example of unsteady state. So various heat treatment process of metal comes under a unsteady state, heat conduction. Then a revolution of earth about its axis, it is surface continuous undergoes a heating and cooling cycle. So it is also a case of an unsteady state. So wherever the temperature is a function of a time, there you find this unsteady state. So in a body there occur a temperature gradient called as the internal temperature gradient. So at a surface the temperature will be different, at a center the temperature will be different, and at a surrounding the temperature is going to be different. So it has been given as a ratio of a difference between center temperature minus surface temperature, center temperature minus surface temperature divided by center temperature minus surrounding fluid temperature. So this Bayes number is the dimensionless number which is going to take care of the internal temperature gradient, and which is going to tell us whether to consider a transient heat conduction or not. So it has been given by HL divided by K, where H is the heat transfer coefficient, K is the thermal conductivity of the object, and L is the characteristic dimension of an object. If Bayes number is greater than 0.1, then internal temperature is greater than 5%. The effect of unsteady state or a transient heat conduction is considered. The characteristic length in the above formula of Bayes number, you have in above relation of Bayes number you have L, which is a characteristic length, and it is given by L equal to volume of the object to the surface area. So for an infinite slab of a thickness B, L equal to B by 2. For a long cylinder of a radius R, L equal to R by 2, and for a solid sphere of a radius, L equal to R by 3. So it is been found out by using a formula of volume of object divided by surface area. The other definition of characteristic number is the distance between a point where maximum temperature occur to the point at minimum temperature occur. Next dimensional term is Fourier number. It has been given by alpha T divided by L square. So it takes care of the thermal diffusivity and tells us about how much amount of the heat energy is being stored, or how the heat is going to be propagated. So Bayes number, basically it is the ratio of resistance to the conductance to the resistance to the convection. In other words, the Bayes number, it is the ratio of material resistance to the surface resistance, while the Fourier number, it is the ratio of amount of heat conduction to the capacity of heat storage in a given volume of a element. So Fourier number, it is the ratio of amount of heat conduction to the capacity of heat storage in a given volume of a element. So temperature variation of a body, it has been given by theta by theta naught equal to e raised to minus HAT divided by rho CPV, where theta is the temperature difference between the temperature at which the point at which the temperature is to be found, that is T, minus Tf, that is unknown temperature minus the fluid temperature. Theta naught is the center temperature minus the fluid temperature. A is the surface area, T is the time in seconds, Cp is the specific heat of a solid, then m is the mass of an object, rho is the density of a solid, h is the heat transfer coefficient, and v is the volume. In a form of Bayes number and Fourier number, the same relation, it has been given by theta by theta naught equal to e raised to minus HAT divided by rho Cp V. It is being given as theta by theta naught equal to e raised to minus c into bi into fo, that is Biot number into Fourier number, where c is the constant. When c is equal to 1, you are going to have theta by theta naught equal to e raised to minus bi into fo. In a lumped heat capacity analysis, no temperature gradient exists. Therefore, the change in the temperature with respect to direction is equal to 0. So theta by theta naught, it has been represented as e raised to minus t divided by RTH CTH, where RTH, it is nothing but a thermal convective resistance and CTH is nothing but a lump thermal capacitance. So it has been given as RTH equal to 1 upon HA and CTH equal to rho CPV. Lumped heat capacity analysis reduces a thermal system to the number of discrete lumps and assume that the temperature difference inside each lump is negligible. Therefore, the temperature gradient inside the lump is considered to be as a 0. And the next is thermal time constant of a thermocouple, where theta by theta naught equal to e raised to minus HAT divided by rho CPV. It has been represented in a form of a thermal time constant. It has been given as theta by theta naught equal to e raised to minus t divided by tau, tau equal to rho CPV divided by HA. So it is thermal time constant of a thermocouple. So time constant indicates the sensitivity of a thermocouple, and it should be small as possible as a range of 0.4 to 0.7 from the practical application. So this thermal time constant of a thermocouple is going to indicate the sensitivity of a thermocouple. So the different form of a theta by theta naught, first in a form of a Fourier and a Biot number, second in a form of a lump resistance and a capacitance, and third it is in a form of a time constant. Then we have a concept of a Hassler and Glober charts, where we have, it is also called as a temperature history chart, where the Biot number is greater than 0.1. We prefer this Hassler and Glober chart, where there are two kind of charts: the temperature distribution, that is theta by theta naught versus Fourier number, and the second chart, a temperature distribution, that is theta by theta naught versus the Biot number. So it will be different for infinite slab, for cylinder, and for a sphere. So this is how we have covered a third unit. The first unit tells us about the introduction. I will just revise it quickly. The first unit tells us about the introduction, then one dimension heat conduction steady state without heat generation. We have shown the differential equation. Then the three mode of heat transfer: conduction, convection, and radiation. Then we have seen the Fourier law, Stefan-Boltzmann law, and the Newton's law for cooling. Then we have seen the structures, the different kind of structures, that is solid cylinder, hollow cylinder, then a sphere, and then the slab or a wall. We have derived the relation for a heat transfer rate for a slab, cylinder, and for a sphere. Then we have seen the electrical analogy, where we compare the electrical phenomena with the heat transfer phenomena, where Q equal to change in the temperature, that is delta T upon resistance, thermal resistance. Then we have seen a concept of thermal conductivity, thermal diffusivity, thermal contact resistance, and the last one and the most important one is critical radius of an insulation. In second unit, we have gone through the concept of a one dimension steady state heat conduction with a internal heat generation, where we have seen this phenomena for a slab, cylinder, and for a sphere. It is based upon the formula of unidirectional Poisson equation, which we have got from a one dimension steady state differential equation. Then we have seen a concept of an extended surface known as a fin, and the purpose of the fin. The different types of fin depend upon the shape, and the concept of a pin fin, where different types of pin fin available in a nature, that is insulated in fin and a infinitely long fin. Then we have seen a concept of effectiveness and the efficiency, the difference between the effectiveness and the efficiency of a fin, and also we have seen the relation for temperature distribution, efficiency and effectiveness of the insulated fin and a infinite long fin. And in last chapter we have seen, the first chapter was in last unit we have seen the role of insulation, and the second chapter we have seen a unsteady state heat conduction, that is transient heat conduction, that is change in the temperature. Net rate of heat flow is equal to rate of change of internal energy, and the most important formula, theta by theta naught equal to minus e raised to HAT divided by rho CPV. So this completes your revision of unit number 1, unit number 2 and unit number 3. All the best for your upcoming examination. Please prefer this notes. This will help you to clear all your concept and which will help you to clear your upcoming examination. Best of luck. Thank you all for watching this video.